we'll look at problem solving, how to do some word problems, and we'll look at 4 particular types of word problems. And we'll start with kind of the idea of solving word problems. We start with a real-life problem that we need to deal with. From that, we get a verbal description of the problem. We then try to move from that verbal description to the language of mathematics. From that, we then get a mathematical problem. And finally, we can solve for a solution. This is kind of the setup, and this is called mathematical modeling. Like I said, we'll look at 4 different types of problems here. The first type of problems we'll look at are simple interest. And we have this formula, I equal to PRT. I is the amount of interest you're gaining. P is called the principal. This can be either the amount of money you are investing or the amount of a loan. Either way. R is your rate. And T is your time in years, which will be very important. Let's look at this problem. Let's suppose we have $14,000 we want to invest. We're going to split this between an insured account that has 5% interest and a high-risk account with 9% interest. And we want to gain $1,020 per year. The idea here is if I look at my total interest that I get, the 1020, this should be equal to the interest given at the 5% rate plus the interest given at the 9% rate. So here's our basic setup. And we're going to do this, or at least start setting this up with a table. Tables can be very useful in these types of problems. I have columns for P, R, and T. We know that the time for both of these is going to be 1 year. We also know the rate pretty easily, 0.05 and 0.09. The principal is the hard one. Essentially, we're going to start by picking one of these to be X. It doesn't matter which one, pick one. Since we have $14,000 to invest, the other will need to be $14,000 minus X. It's the remaining of our investment. To get each of our interest, we now just need to multiply these rows. If I try to do that, my first row, my interest is 0.05x. My second one, my interest is 0.09 times 14,000 minus x. And now we need to add these up and solve. So we add these up and set them equal to our total amount of interest we want. We're going to start by getting rid of the parentheses. So on the right, I have 0.09 times 14,000, which gives me 1260 minus 0.09x. I can combine my x's to get, that should be a plus, 1260 minus 0.04x. From there, I can subtract 1260 from both sides. And that gives me a total of negative 240 equal to minus 0.04x. We can then divide both sides by negative 0.04. And when I do that, I get that x is equal to 6,000. So my 5% account, we should invest 6,000. For the 9%, that was 14,000 minus x, or just the remaining of the 14,000, which is 8,000. The next type of problem we're looking at is called a mixture problem. we're going to mix some lima beans that are 90 cents per pound with 16 pounds of corn that costs 50 cents per pound. And our goal is to make a mixture that costs 65 cents per pound. We're also going to use a table to set up this problem. So we're mixing beans and corn, and then we have our actual mixture. And we have three things that we have here: the actual cost of the product, the amount that we have, and then our total cost. We can fill in some of this pretty easily. We know that lima beans cost 90 cents per pound. We know that corn costs 50 cents per pound, and our mixture is 65 cents. We also know that we have 16 pounds of corn, and ultimately our goal is to figure out how many lima beans we need to mix in. So we'll call that X. Since we're mixing these, our total at the bottom is 16 plus X. As far as our cost, well, if we multiply the cost per pound times the amount of pounds, we get our total cost. So the first one, 0.9x. The second one, 0.5 times 16, which gives me 8. And then my last one is just 0.65 times 16 plus x. Ultimately, our goal here is to take how much the beans cost plus how much the corn cost and get the mixture. So now I have the equation I need to solve. We'll start by multiplying through on the right-hand side to get rid of the parentheses. So I have 0.9x plus 8 is equal to 0.65 times 16 is 10.4 plus 0.65x. We do need to try to get everything on one side, so I'm going to start by subtracting 0.65x from both sides to get the x's together. On the right, 0.9 minus 0.65 is 0.25x plus 8. And on the right, we just have 10.4. Now we can subtract 8 from both sides. When I do that, I get 0.25x is equal to 2.4. We can then divide both sides by 0.25. And we end up with x being 9.6. So we need 9.6 pounds of the lima beans to correctly make this mixture. The next type of problem we'll look at is uniform motion. And for this one, we need the formula D equal to RT. D is for distance. This is the total distance that we travel. R is our rate, also known as the speed. And T is our time. We have this problem. At 9 a.m., a car starts driving at 40 miles per hour. An hour later, another car leaves the same place. We are going to assume that they're traveling in the same direction, and is now driving at 60 miles per hour. We want to know at what time the second car would pass the first. So we have our first car and our second car, and we'll set up a table. This time with D, R, and T. The R part is pretty easy to fill out because we already are given that, 40 miles per hour and 60. For T, we don't know this. I'll let the first one, I'm just going to actually call it T. The second one would be T minus 1 because they left an hour later, so they've been driving for 1 hour less. And we want to know when these two things are equal. So I'm actually trying to find when 40T is equal to 60 times T minus 1. I can multiply this out to get 60T minus 60. From there, I can subtract 60T from both sides. When I do, I get negative 20t is equal to negative 60. And then dividing both sides by negative 20 gives that t is equal to 3. If the first car left at 9 o'clock and has been driving for 3 hours, it is now 12 o'clock, noon. Next, we'll look at constant rate problems. The idea of these problems is we have people who can do the same job during 2 different times, and we want to figure out how much time they can spend working together. So we have 2 people that for now I'll call person A and person B. Person A takes 12 hours to complete a job by themselves, and person B takes B hours to complete a job by themselves. If I do 1 over person A's time plus 1 over person B time, I can get 1 over their total time. So T will be the total time that it takes if they work together on this job. Let's assume that Andy can paint a house in 12 hours. Bobby can paint the house in 8 hours. We want to know how long it would take if they tried to work together. Well, Andy does it in 12 hours, and Bobby does it in 8 hours. And this should be equal to their total time, T. We may want to simplify this a little bit. 1 over 12 plus 1 over 8. If we try to add this, we get 5 over 24 is equal to 1 over t. If I now multiply both sides by 24t, that would give me 5t on the left and 24 on the right. We can then divide both sides by 5, and we get that t is equal to 4.8. So if they work together, they can do this job in 4.8 hours.